Hey, so this session is about accelerating IoT transformations with AWS IoT and its partner community. So my name is Prashant Adiraju. I'm the global segment leader for industrial IoT within APN, which stands for the AWS Partner Network. And I'm today joined by Thomas Cummins, who's a partner solutions architect at APN as well. And I'm also excited that Sean Monteith, who's a customer of AWS IoT, will also be joining us in this session, talking about some of the innovation that iDevices is doing in this space. Yeah? So I've been in the technology industry for 20 plus years, and 4 of those 20 years have been in IoT. And it's a fun space, right? As this technology is sort of driving change in many markets. But if you step back, and not that long time ago, right, if you were a successful company, the assumption was that you're going to remain successful for a very long period of time. But that assumption doesn't hold true anymore. And today, the average lifespan of an S&P 500 company is down to like 15 years. And yet, companies spend probably 2/3 of their IT budgets just keeping the lights on and just pure maintenance versus innovation. Right? And if you look at Kempe, right, they're like an 8-year-old Finnish company, and they are a pioneer in this welding industry. And one of the key things that they find in this industry is there's a significant demand for skilled welders, and there's a shortage of that kind of talent. And Kempe approached that problem and also modernized the industry by doing 2 things, right? One is they built out what's called as a welding management software, and then they connected one of their flagship products to the internet. And as a result of doing that, they were able to do 3 things, right? One is based on parameters that were stored in the cloud, based on the profile of the job and the skill set of the welder, they were able to apply those parameters and then bridge that skill set gap. The second thing is they were able to authenticate, essentially bring the right person to the right job. And then they're collecting data from all these welding jobs, and as a result, they're able to drive compliance. Now, by doing innovation in this manner, they built this software on AWS IoT. They were able to do this at 50% less cost. They were able to do it 6 months faster. It would have taken them normally a year to do it. They were able to do it in 6 months. And then the third aspect of it is agility. Right? They were able to now drive significant feature updates every week, like do 10 updates every week versus waiting once in 6 months to do these updates. So if you look at it, IoT is all about driving transformational outcomes. Now let's look at a few more examples, right? Here is several sets of customers that are today transforming their businesses with IoT and with AWS IoT. There's Vizio that's connecting millions of its smart televisions. There's Rodimatic that's making cooking smarter. They're making flatbreads using their smart cooking gadgets. Got Deutsche Bahn that's managing its wide fleets of trains, tracks, and assets using AWS IoT. You got Module that's actually reimagining the insurance business model using AWS IoT with their smart belts. You got companies like Pentair that's improving its water filtration systems. You got Valmet that's improving the quality of paper. You got NL that's doing energy management. You got companies like Thermo Fisher that's monitoring its lab equipment and doing condition monitoring of those assets. So in the end, what IoT does to these customers is essentially several things. Right? It's allowing them to develop new business models like what Module does, or the products get better over time, like what iRobot does with its robotic vacuums. Or you got better relationship with the customers, like Vizio with its smart televisions. Or you got increased efficiency, like how Valmet uses AWS IoT to predict the quality of paper. So in the end, it's all about either revenue growth or reducing costs. And if you're able to do both these things at the same time, it's even more compelling, right? Now, there's one other thing that's common, right, is that all of these transformations involve partners, and it involves different kinds of partners. And that's essentially what I want to talk about in this session is 3 things. We'll talk about the approach to transformation with AWS IoT and its partner community. We'll talk about how this partner community is putting together a set of customer-facing accelerators to essentially accelerate transformation. And the third thing will leave you with a set of pointers in terms of how you can find a partner, you can become one, and also grow as a partner. So let's dive into the first topic, right, which is about this approach to transformation with the AWS IoT partner community. Now, if you look back, right, IoT is about connecting devices, collecting data, and then using that data to drive transformational outcomes. Now, the analysts, right, they estimate somewhere around 79 zettabytes of IoT data is going to get generated over the next 5 years. Now, must be wondering, what is a zettabyte? Yeah, it's something like 1 million petabytes. And you're going to ask me, what is a petabyte? I think the simplest way to look at that is the internet at the end of this year is going to generate 2 zettabytes of data. So what we're talking about is 40 times of what the internet is today is what the IoT data is going to be in about 5 years. Now, it's about this devices data outcome virtuous cycle that we're talking about. So whether it is Vizio connecting its millions of televisions, or Rodimatic connecting its cooking gadgets, or Kempe connecting its welding equipment, or Deutsche Bahn connecting its trains, see, there's a set of commonality across that diverse use case set. And it is this commonality that AWS IoT provides. Right? It's about providing a breadth and depth of features, multi-layered security, got integration with AI, it's sort of proven at scale. And what AWS IoT does is 3 things, right? One is AWS IoT device software, which is about connecting devices securely, collecting data, and then delivering local intelligence, whether or not there is connectivity to the cloud, right? The second thing is about control and communication services, which is all about controlling and managing fleets of devices. And third thing is AWS IoT Data Services, which is once you bring all this data in, how do you drive insights out of that data? Now, what the partner community does is builds on these foundations of AWS IoT and drives transformational outcomes for customers. And that's, in a sense, what the partnering approach is for AWS IoT. Right? So let's dive a little more into the partnering motion, right? But before I do that, let's just level set, what is APN? So APN is essentially the AWS Partner Network, which is the global partner program for both technology and consulting partners that leverage AWS to build solutions and services for customers, right? And what this partner community does, it helps companies build, market, and sell their offerings by providing, valuable business, technical, and marketing support. Now, greater than 90% of the Fortune 100 companies use this partner network. And a majority of the Fortune 500 companies use this partner network to drive a variety of transformational objectives. Now, when you look at IoT, now the stack is complex. And customers have a diverse set of use case requirements. And even if you take 2 customers in the same vertical, you're going to find a diverse set of needs. And at reInvent last year, we introduced this approach called the edge-to-outcome partner approach. And what this edge-to-outcome partner approach is about providing a diverse set of partners spanning from the edge to cloud to address 3 things, right? One is to make solution build with AWS IoT easier, to make deployment of those solutions faster, and reduce the time to value for customers. Now, you can think of an automotive OEM in the Midwest, and if you're in the manufacturing space, the key thing that you care about is operational equipment effectiveness. Now, in order to do that IoT use case, if you're trying to add IoT to your manufacturing operations, you need industrial connectivity, you need edge gateways to collect data, do some local intelligence, send the right data back to the cloud, you need applications in the cloud, you need some system integration expertise. Or you might be adding IoT into your products, you might be building an Alexa-enabled light switch. You might need the right qualified silicon to build those kind of products. Now, regardless of where you are in your IoT maturity, regardless of what the use case is, and regardless of maturity of the solution, what this partner community that spans silicon vendors, ODMs, OEMs, gateway providers, network and communication providers, ISVs, and system integrators and global SIs, what they do is 3 things, right? What they do is they help differentiate this partner community by providing domain-specific solutions built on the foundations of AWS IoT. The second thing is about coverage. Essentially, depending on what your use case need or where you are in the maturity journey, providing you with the right hardware and software partners. And the third thing, which is very important, is engaging the right integration partner in helping to execute pilots and helping to execute and manage deployment so that you can drive scale and drive into production. Now, at re:Invent, when we announced this edge-to-outcome partner approach, over the last year, we've seen a significant growth of this partner community. And this community of partners, right, spans qualified silicon partners that work with AWS IoT, partners like Ambarella, Cypress, Microchip, Intel, got Qualcomm, NXP, NVIDIA, right? You've got Renesas or ST Micro. And what they're doing is qualifying their products to work with AWS IoT, and what we call that qualification is entitlement, and there's billions of devices that are entitled with AWS IoT today. The second thing is you look at a several set of qualified products that are coming out from our edge hardware partners, or the likes of Banner Engineering providing sensors. You've got edge servers that coming out players like Lenovo, Rigato, AdLink, or Advantech. And you've got cameras like from players like Altec or Vivotech or Sercom. Now, look at the other dimension of this, which is all around IoT solutions, which are domain-specific solutions or solution accelerators, which are the likes of what NXP might provide for an Alexa voice service kit with AWS IoT Core integration. Or you might look at an Isla that provides a smart home application, or a Hitachi Vantara for a manufacturing insights, or a Vertex that provides a digital twin solution. And then the last piece of this is the AWS IoT practices, which are coming out from system integrators and global system integrators. And these sets of players include players like Deloitte, you got Accenture, you got Tensor IoT, you got Onica, you got Open System Technologies. And these players provide practices for key verticals of manufacturing, connected products, oil and gas, utilities, and a whole host of others. Now, in addition, this partner community is also driving AWS IoT competencies where they have achieved a certain set of technical proficiency and customer proficiency. And there are 40+ partners today that have a variety of competencies, which is competencies at the edge from players like Digi, Intel, Microchip. Or you've got players like Machine Shop for gateway technologies, or a Tuya or an Isla for a platform. Right? And then you've got SI and Soracom that provide connectivity technologies, or players like Persistent, Luxsoft that are providing very specific expertise in consulting. Now that brings me to this slide, which is about what are the set of accelerators that this community of partners are providing to customers. And what I'll cover in the next set of this presentation is about a set of 5 accelerators. We'll start with the silicon acceleration, which is provided by our silicon partners to make building connected products easier and faster. Then we'll talk about the device qualification, and hardware and devices are very fundamental to IoT, and we'll talk about what the device qualification program does, which is essentially to build out an edge hardware partner community. We'll also talk about how this partner community is going through the motion of a build, market, sell journey to make it easy to bring to market domain-specific solutions. We'll also cover some of the practices that the GSIs and SIs are doing to really accelerate deployment and make it easy to deploy these solutions. And solutions are an important aspect of it. We'll talk about the wide variety of solutions that this partner community is building. So with that, let me go into the first section, which is about the silicon program. Now, with this program, right, we essentially focus on working with our silicon partners to have their products qualified to work with AWS IoT device software. This could be AWS IoT like FreeRTOS that works for microcontrollers, or IoT Greengrass that works for more microprocessors. Now, through these qualified paths, and these qualified paths become the basis of what we call as entitlement. And this entitlement, essentially think of it as a collection of qualified paths that this silicon partner community provides. And it could be like an evaluation board or a development board that the silicon partner builds. And by qualifying it to work with AWS IoT, we sort of have an entitlement towards AWS IoT services. Now, this evaluation board may not typically represent any particular use case, but what the silicon partners do is take an additional step of build out something that's very use case specific. They might build a reference kit, and that's targeted at a very particular use case. Now, both of these type of qualified kits, once the silicon partner releases it, it makes it easy for customers to go discover it using our partner device catalog. Let me give you an example, right? If you look at, here's an example. Look at the picture on this left. Here's TI and AWS. They work together to qualify FreeRTOS, which is AWS IoT device software for MCUs. And OEMs can then use those boards in their products and do not have to focus on the free RTOS or the connectivity or the cloud or any of the OTA functionality. And further, here's someone like Interpret that's taken that particular evaluation board and then built out a reference kit that's very use case specific for vehicle fleet management. So this is something like you would do an OBD2 device where you can build an application to drive fleet management applications. And further, here's the end product that you see on the far right, which is like an OBD2 device that can be used in any vehicle that has a standard OBD2 port and to provide a wide range of applications from fleet management to personalization services. Now, with this in context, what I would like to do is invite Sean up on stage. And Sean was going to talk about his experience in building these connected products. Welcome, Sean.
Thanks, my pleasure. Thanks.
So Sean, I'm curious, you've gone through a connected product journey, but maybe it'd be good for the audience to first understand what does iDevices do?
So the short answer is that we do home automation products and we do lighting control. And so we're part of a bigger corporation, Hubbell Corporation, which is a $5 to $7 billion company. There's 80 plus brands, business units under that umbrella. It includes power systems, which is basically from utilities right through the infrastructure, right to your smart meter that's outside your house. That's a Claire out of St. Louis. They make that product. And then we're really behind the meter. So we're inside the house or we're inside the retail space. And so what we're doing for lighting, we're not making the lighting fixtures themselves, but we're putting the business intelligence, the connectivity, the analytics. That's what we're working on now.
Got it. So you're sort of in the lighting business. What are some of the trends that you see in this business?
If you just think about, Hubbell's a 130-year-old company. And if you just go back 40 years, there really hasn't been much innovation in lighting controls, the lighting fixtures themselves. And so really our mission there is to start introducing sensors. So, they have occupancy sensors now. They're not really intelligent, ambient light sensors. And really, if you repurpose some of these sensors, and now you can start to do heat mapping. So not necessarily counting the number of people that are in aisles in big box stores, but you can actually extract the activity that's going on in those spaces. And based on that, the store can start to rearrange their products and figure out what's there. So cameras is another thing. Computer vision is a big area that we're looking at right now for the light fixtures. And so that's some of the things we're looking at for lighting.
Pretty cool. So how do you, when you think about these trends and sort of think about connected products, I'm sure there are a set of challenges that you work through. Maybe it'd be good to baseline what those challenges are.
Yeah, so one of the services that we used was AVS integration for AWS IoT, which is really just a lightweight protocol for AVS, so the Alexas of the world. So, we've actually put that into a product. And so, some of the challenges there is, you talked about silicon partners, right? So that is extremely important to us. I wasn't going to go down a road, and if this silicon partner wasn't AVS certified, I'm not looking at them. And so we chose NXP. They basically were certified. We don't have the capabilities to really go out and design silicon. That would take us 3 or 4 years. I have an ASIC background. Yeah, we could do that, but we don't want to spend the time and resources on doing that. And so our goal was really to focus on developing a premium product, right? So this Instinct product, it's a light switch. It's got 2 microphones in it and speaker. We wanted a premium product. We wanted the sound to sound right. We put an LED ring in there for a little surprise and wow. We went through a focus group, and the number one thing that the focus groups wanted, they wanted it to look like a light switch. And that presented a challenge. How do you get the sound out of a paddle switch without putting holes in it? Yeah. And so, those are some of the other thing is time to market. Typically our design cycles are 9, 12, 18 months. It really depends on the complexity of the project. And so when we used the new service, the lightweight version of AVS, and NXP's software and Amazon free RTOS, we cut our design cycle down to about 4 months.
Got it. So that brings to this question of, I think you just touched upon this. You use AWS IoT plus NXP. Can you elaborate a bit more of how you picked these 2 technology choices?
We've been using AWS for a while, but it was really just a kind of, between the silicon partner, the new lightweight AVS service, a more controlled cost. You know, everybody assumes or expects that cloud is going to be free. It's not free. And so what you end up having is you have a recurring cost, right? So you sell this product and there's a recurring cloud cost that happens over the life of the product. It could be 10, 15, 20 years for a light switch. Some of them are out there for 50 years, the dumb ones. So it was really important for us to get costs under control, understand what it is at the time of the sale, the bill of material cost. And so Amazon or AWS has really done some improvements in cutting costs down, making it very affordable to really put Alexa anywhere or connectivity anywhere.
Got it. So I want to just sort of maybe go back to your point about your design cycle. And I touched upon this in the prior section, which is about how do we accelerate time to market? So if I take, for example, AWS collaborated with NXP to sort of qualify Amazon free RTOS on their IMXRD 1060 MCU. Right? That was one of their evaluation boards.
Yep.
And then NXP further took that and built out a reference design with Alexa voice service integration with AWS IoT Core.
Yep.
So how did that help you jumpstart your development efforts?
Yeah, it absolutely did, because we were going, you know, typically when you do an AVS type product, it's Linux based, it's very heavy, it's a multi-core processor. And so we basically had developed a product that was AVS based on Linux. It had sound detection and stuff like that built into it. And so we basically pivoted. So when this perfect storm came together, we had to pivot. We didn't have development boards. We had our own boards, but they were based on a multi-core processor. So the fact that, you know, NXP had a 1060, which actually ended up being the RT106A, we used that. We had a proof of concept that you actually could show the team that this is actually possible in this form factor, because there's a lot of things that are foreign. Speaker box development, microphone, you know, some of these things are foreign to some companies. I'll admit we didn't have microphone experience. So it was really important to use those. And then the best part of it is Amazon free RTOS was available and supported on the dev boards. We eventually spun our own board within a couple of months. So it was a 2-month window that it helped us out.
Got it. So how is Instant doing in the market?
It's doing really, really well. It's our best launch product to date. You know, some of the other products we have done, we do in-wall dimmer switches, connected dimmer switches, no hub, light switches, outlets. This by far is the best launch that we've had. We, you know, we target consumer and we also target builders. And builders is a little bit slower process. I think to date we have 15 of the top 30 in the US, and it's their timelines when they start to build out the developments. And really what their differentiator is, their competition is existing inventory, so homes that already exist. And really they're looking to differentiate new homes by putting connected devices and intelligent devices. And really where this is going is adding sensors, pushing innovation within the gang box or in light switches, connected light switches, getting those sensors out there, and then you can start to push into other areas, age in place, et cetera.
Cool. Congratulations on a good product, and thank you again for being an awesome AWS customer.
Thank you for
taking
providing those partners. They're really important.
Cool. Thank you.
Thanks.
All right. So with that, right, I want to do is sort of wrap up that first section, which is about the silicon acceleration. We talked about 5 mechanisms, so this is one of those 5 mechanisms. And now let's shift into devices. Now, if you look at any IoT solution, it requires many types of devices. You need sensors, you need gateways, you need cameras, and you also need silicon products like the ones that Sean talked about that go into connected products like the iDevices one. Now, at reInvent last year, we launched the AWS Device Qualification Program, which is a global hardware qualification program that allows partners to essentially qualify their devices with AWS IoT services. And the mechanism is APN Partners can self-qualify their devices for Amazon free RTOS, for AWS IoT Greengrass, or AWS IoT Core, or even Kinesis Video Stream, which is about securely streaming video data to the AWS environment. And the devices qualified under this device qualification program get listed in the partner device catalog. And what that partner device catalog does, it makes it easy for AWS sellers, APN partners, and customers to discover what are the hardware devices that they might need for their IoT projects. And in the course of last year, we've added 350 plus different kinds of devices from 90 different partners. And this is a wide range of hardware devices. And you can see on this list, right, you see players like NXP and TI that have validated their microcontroller boards to work with Amazon FreeRTOS. You've got Advantech, Beckhoff, and Intel that have validated the gateways to work with AWS IoT Greengrass. And one of the players here, Rigado, right, like Prologis, is establishing a digital infrastructure platform to do real estate management. And they selected Rigado IoT Gateway, which has been qualified to work for AWS IoT Greengrass. And then you've got Extreme Networks or Vivotech that have validated their cameras to work with Amazon Kinesis video stream, is essentially about securely transmitting video feeds to AWS. So that was the second effort that we're doing, which is all about building out a robust edge hardware ecosystem. Now let me shift into the service adoption piece, which is all about how we want to make it easy for partners to build, market, and sell solutions. And there are many dimensions of solutions. And so this effort is to simplify the complexity of IoT and make it easy for customers to really consume solutions. And the objective here and the program is all about to drive differentiation of the community. And this was established in the beginning of 2019 this year, sort of make it easier for our OEM connectivity partners, ISVs, and GSIs and SIs to build, market, and sell IoT solutions using AWS IoT. Now, the partners and the program offers three key benefits, right? One is technical expertise to build solutions using AWS IoT. And then the second piece of it is to help accelerate the market and sell motion. And we prioritize engagements essentially based on partners who sort of monetize their business based on domain-specific capabilities and drive differentiation and ultimately derive better customer outcomes. Those are a set of the partners that we would sort of prioritize and drive a build, market, sell motion. Now, here's an example where you've got Verizon and Domo who have come together in sort of a multi-partner motion, have packaged together an asset tracking solution, wherein Verizon has a critical asset sensor package and a set of connectivity services that are then packaged with a Domo asset tracking application, which sort of makes the package complete. And then a set of marketing activities ranging from APN blogs, putting it in solution space to make discovery of these solutions easier for customers, field-ready kits so that if a customer has an asset tracking objective, we're able to present a package to meet that requirement. And then also making the buying of this package easier through our marketplace efforts. Right? So wherein the asset tracking application from Domo is listed, and then that listing is now part of the AWS build the customer could consume. So in essence, this is sort of the build, market, sell motion that we're driving in this partner community. And what I would like to do next is, it's a good segue to talk about solutions. Now, you look at solutions, there are many definitions of what a solution can be. So I want to sort of bring this picture back, which is about this edge to outcome partner approach, and sort of map to that, what are some of the different types of solutions that this partner community is bringing together? Because ultimately, customers have diverse solution needs. And they're either seeking to add IoT to their operations or seeking to add IoT to their products. And those two objectives have different solution requirements, right? So if you look at it, let's start with the stuff on the top left, which is about a reference and a development kit. This is typically built by our silicon partners and is the examples like the NXP reference kit with Alexa voice service integration for AWS IoT Core that iDevices use to build a connected product. Right? That's sort of point one. The second one is about the qualified devices, which is about the AWS device qualification program, and wherein we are qualifying cameras, sensors, and gateways. And these products are listed in our partner device catalog, like the Rigado IoT Gateway example. Then you've got domain-specific examples, like Isla Smart IQ, or a Hitachi Manufacturing Insight solution, or a Deloitte Smart Factory Fabric. And then the last one here is what you see in the bottom is the edge to outcome package, which is a combination of qualified devices, could include edge hardware, could include edge software, could include connectivity, could include a domain-specific application from an ISV, and it could also include a set of IoT practices that our global system integrators and SIs might provide. Like we talked about the Verizon Domo as a hardware plus software package for a well-defined use case like asset tracking. Now, what we have seen is every one of these solutions is quite unique. And it's going to require a different combination of partner technologies to solve that use case. But what we've seen to be successful is when partners bring these technologies together, they exhibit certain patterns. And this is probably a good segue for me to invite on Thomas, who's going to talk about what are some of these design patterns and how does it make it easier for this community to build out solutions. Thomas?
Thanks. Thank you, Prashant. Good afternoon, everybody. My name is Thomas Cummins, and I'm a partner solutions architect at AWS specializing in IoT. And so I work with our AWS partners to architect IoT solutions where they're leveraging IoT technologies and using the AWS IoT services. So Prashant mentioned that, walked us through all the different programs we have in place to help partners build IoT solutions. But I want to dive into sort of some architectural design patterns that actually get used when we build these solutions. So first, what are we talking about when we mention IoT design patterns? So building IoT solutions can be challenging because there's never any use case that is exactly the same as any other use case. But they often, from one solution to another, they often contain components that are solving the same problem in similar ways from use case to use case. So these reusable components are the IoT design patterns that we promote as best practice with our AWS partners. And so these design patterns are at the right level of abstraction because they're granular enough where we can map the components of these design patterns to the specific features and APIs of the AWS services, but then they're comprehensive enough where they're actually usable from one use case to another. So why should we use these IoT design patterns when we're building solutions? So when I work with AWS partners to build these IoT solutions, we always start with the customer need and work backwards from that. After the customer needs defined, you can define your solution requirements, and from there you can decide what IoT design patterns you want to implement in order to achieve a certain capability, such as establishing a control plane for device management, security control, a data plane for telemetry data ingestion, or maybe an integration with a third-party IoT platform. And so these design patterns exhibit the characteristics of well-architected IoT solutions in that they have single sources of truth for device management. They have separation of concerns, for example, establishing both a control plane and a data plane for devices. And they have decoupled architectures. So we're trying to separate IoT producers and consumer solution components. So implementing these IoT design patterns helps our partners build IoT solutions faster, and that's what we're trying to help them do. So today we'll take a look at just 3 of these design patterns that we see partners use often. For each one of them, we'll want to take a look at what is the business problem the partner's trying to address. Number 2, what is the technical challenge they're trying to overcome? And third, what is the AWS service that they're actually going to use to implement the design pattern? And so these patterns are ingestion and analytics. So how can data be ingested from devices and other IoT platforms into the AWS cloud, processed into a format that's ready for downstream consumption by an application? Number 2, downstream delivery. So often partners already have their data ingestion component of a solution built, and they're happy with it. But the downstream delivery of data to customers is a challenge because every new customer they bring on has sort of different requirements on how they want to consume the data. And 3, let's look at a common pattern for building an IoT data lake. So here we see all of the AWS IoT services that are available for partners to build IoT solutions. We see everything from software that runs at the edge, including AWS IoT Greengrass, Amazon for YARTOS, and our IoT device SDKs, as well as services that run in the cloud, such as AWS IoT Core and AWS IoT Analytics, just to name 2. But again, when we work with partners to build IoT solutions, we don't try to just apply a diagram like this to a solution. We always work back from the customer need to define the solution requirements, and then from there, the architecture that gets developed emerges, and with that, the design patterns that get implemented. So the first pattern is this decoupled ingestion and analytics pipeline. So these are customers that need a solution to bring data in, process it, and put it in a format that's easy for consumers to receive. And so one successful engagement method that we're seeing with partners is two or more partners coming together to actually build a complete IoT solution. So we'll get into that in a little more detail later. So often these partners, when there's two or more involved in delivering a single IoT solution, they'll often serve in either a producer or consumer capacity. So in this context, what we're talking about here is a producer. We're thinking of solution components that are producing, aggregating, or publishing data from the edge to the cloud. And consumers, we're thinking of components that are consuming that data and then delivering some sort of value to the customer. So whether that be the location of assets, as in the case of an asset tracking solution, or the health of an asset, as in the case of an asset condition monitoring solution. So this is a pattern that's actually worked in two of those different use cases. And so by promoting the use of well-known and proven IoT design patterns, we help partners work better with each other, and then we help those partners build IoT solutions faster. So we'll take a little bit deeper look at that pattern right there. So what we're looking at here is on the left side, we see the service AWS IoT Core. And within that, we see a feature labeled the device gateway, allowing you to bring in data to the AWS cloud from either devices that are in the field or other IoT platforms that are either running in an on-premises environment or a cloud environment, over a number of different protocols, including MQTT, HTTPS, or MQTT over WebSockets, using a variety of different authentication mechanisms, including X509 certificates, SIG-v4 signing, or even custom authorizers. And so whether it's periodic updates of location data or from hundreds of thousands of devices in the field, or just data streaming in with event data from a single industrial gateway in a smart factory use case, IoT Core can ingest that data and then deliver it to a number of AWS services through its native rules engine, in this case, AWS IoT Analytics. And from there, it can be processed, filtered, and formatted in a way that's ready for downstream consumption. So now we'll bring back a solution that Prashant actually brought up earlier. And so this is the asset tracking solution that Verizon and Domo built together. And they actually implemented the design pattern that we just went through. So Verizon has basically small devices that are battery operated that track the location, as well as some other telemetry features of an asset, like temperature, humidity, vibration detection, so fall detection, things like that. It publishes data over their cell network to their own ThinkSpace Core IoT platform. From there, they have a cloud connector that moves the data over to IoT Core. Then we route it into IoT Analytics through the native rules engine. It's then formatted for consumption for Domo. So Domo builds the asset tracking app that the customer interacts with, and they're actually consuming data sets from IoT Analytics using the IoT Analytics API. So now we'll go to a completely different solution here. This is for an asset condition monitoring solution built by Banner Engineering and Domo, but you'll notice it's using the exact same design pattern here, and so that's the point we actually want to focus on. So this is a solution that Banner Engineering built for their customers that basically wanted a virtual check engine light for their high-value assets in a discrete manufacturing environment. And so, for example, we're talking about extremely expensive electric motors where they want to put vibration monitors that Banner Engineering manufactures onto those motors. And if they detect any sort of vibration pattern that is abnormal, they want to send a technician to go check on that asset. But they're ingesting the data through the same pattern that we just went through IoT Core, then into IoT Analytics, and then Domo created a new application for asset condition monitoring, but they were able to leverage that same connector they built that works in the asset tracking solution. And so this is important because we're allowing AWS IoT partners to work together more easily. They can build the next solution and the next solution easier and easier every time, and it allows them to focus on their core competencies. So Domo can focus on building excellent dashboard applications that their customers love, and then Banner Engineering and Verizon can focus on what they want to focus on, which is producing data in the real world, sending it over networks to the AWS cloud. So the next pattern we'll take a look at is the downstream delivery of data to consumers, and so legacy migration to do that. So in this case, we're talking to partners that they have legacy downstream data delivery solution components that are already working, but every new customer they bring on board, it's a challenge because they have basically custom message routing logic that they've built. So every new customer they bring on board, it's a development and maintenance burden for their own engineering team. So they want to solve that challenge. In addition, they want to implement a new solution that does not disrupt their current operations. So basically, they have a legacy delivery method. They want to implement a new one and then eventually phase the old one out. And so here we'll take a look in a little more detail about what they're actually using right now. So they actually have built their own message ingestion and then message processing and routing logic, and they're running that on Amazon EC2. So they build and maintain all of this that's running in the AWS cloud. Eventually, they move it over to Amazon S3 buckets, and then that data is able to be consumed by consumers. The challenge is that, again, every new customer they bring on has inevitably a little bit different message formats and message processing requirements. And again, it's a burden on the development team just to be able to implement that feature and then maintain it going forward. So the new solution that they're implementing is taking advantage of AWS IoT Core here, where they're keeping their existing message ingestion component. They're then moving the data to AWS IoT Core, and then using the native rules engine, they're routing it to the Amazon S3 bucket via Amazon Kinesis data firehose. So that enables them to provide some data filtering and processing in flight, basically, as it goes into the S3 bucket. So every new customer they bring on board, they don't have to develop that message routing and processing logic every single time. It's built in natively to AWS IoT Core and Amazon Kinesis data firehose. So eventually they want to phase out the legacy application and go with this architecture so that each new customer they bring on board, they can immediately focus on what's the new features the customer wants, and they don't have to worry about the maintenance burden of maintaining all of that new business logic because it's native within the AWS services. The last design pattern that we'll take a look at is an IoT Data Lake. So for partner IoT solutions with the data ingestion components tightly coupled to the data consumer components, it makes it difficult to bring on new customers or add additional analytics capabilities at the application layer. And so using AWS IoT Core and Amazon S3, it provides a simple way to build an IoT data lake that decouples these two. So if we look at one partner we're working with and the legacy solution they currently have, again, they have built their own message ingestion and message processing and routing and storage components that are running on top of EC2. So they build this, they maintain this. The issue, again, is that every new customer that they want to bring on board, they have to develop custom data push mechanisms to move the data to those customers. So if every new customer has a different way they want to receive the data, that just is all the more work that the partner has to do to develop that capability and then launch it and maintain it running on top of Amazon EC2. So that's a challenge they want to overcome. So the solution they're looking at here is kind of has two components within the solution here. The first one is they're using an AWS IoT Core to basically receive messages from that existing message ingestion component, which they're keeping, and they're going to run on Amazon EC2. They're then using the native rules engine again, but this time they're routing it directly into Amazon S3, right into the data lake. And we'll go into the specific mechanism they're using to do this in a moment. But the second component of the solution is they needed a way, they basically wanted to document an API, hand that to every new customer they bring on board, and say this is how you're going to access your data once it's in our data lake. And they want that to be a serverless architecture. So what they're using is Amazon API Gateway with the Lambda backend in order to fetch data from that data lake when they bring on a new customer. And again, eventually they want to retire that legacy mechanism there. So finally, let's look at the specific mechanism that they're using to move data from AWS IoT Core into Amazon S3. So they're taking advantage of the MQTT topic structure that exists within AWS IoT Core. So it's color-coded here to kind of show you go from the topic structure within the MQTT topic, and you can actually map that into the S3 bucket and prefix, as well as use a unique date timestamp for the object name. So this is actually a capability you can build in within the rules engine within AWS IoT Core. So it's a serverless architecture with minimal code that you just configure within AWS IoT Core to basically take messages coming into AWS IoT Core, which we saw earlier, you can bring in from devices or other IoT platforms, and then actually form that into the S3 objects which sit in your data lake, and that's what that Lambda function is going to go fetch. That's attached to the API gateway to pull into the customer. So if you're a partner or customer that is developing an IoT product or service, or you're a customer that needs to solve a business problem and you think an IoT solution or IoT technologies might help, what does AWS offer to make that happen? So here's sort of a summation of everything we bring to bear to help partners and customers. AWS makes it easy to find IoT solutions built by our partners, and then we offer hardware, software, and documentation to help our partners build new IoT solutions. And so in terms of software, we of course have our AWS services that are running for IoT, both in the cloud and at the edge. In the case of AWS IoT Greengrass, for example, SiteWise, Amazon FreeRTOS, our IoT device SDKs. So whether you're running this on a battery-operated microcontroller or a full-on industrial gateway at the edge, we have software that can work for that. And then for hardware, we have our partner device catalog that offers a wide range of qualified hardware that works with AWS IoT services. Documentation, there's documentation that show our best practices for building IoT solutions, how to take advantage of the MQTT topic structures, for example, in our white papers. We have reference architectures and other technical blogs that are available on the AWS blog site and IoT Atlas. And then, of course, we have our AWS IoT service documentation. And then finally, at the top here, you can actually access complete IoT solutions via the AWS Marketplace, AWS Solution Space, or the AWS Partner Solutions Finder. So to review, we help our partners use IoT design patterns to accelerate the solution development to build reliable, scalable, performant, cost-efficient IoT solutions. And so with that, I will hand it back to Prashanth, and he'll talk a little bit more how we work with solution integrators to develop and deploy solutions to their customers.
Cool.
So,
thank you, Thomas.
thanks.
Yeah, so we are. No? All right, good. Okay, so we talked about silicon, we talked about device qualification, we talked about solutions, and we talked about the build market sell motion. Now, one important aspect of it is, greater than 70% of IoT implementations require system integrators. And what we essentially do with system integrators is, and let's step back, right? Within AWS, the IoT consulting partners are typically system integrators and global SIs, which are typically professional service firms that help customers of all types as design, architect, build, and manage their IoT applications. Whether you're starting off building a proof of concept, proof of value, and then helping them really drive the transformation journey. Now, one of the key things that we see is that these system integrators, they assimilate the edge-to-outcome partner community approach that we talked about, bringing in the right set of hardware devices, bringing in domain-specific applications, depending on what the customer use case need is. And then deriving a set of scalable solution accelerators that make it more repeatable for them to go drive this thing over and over again. So here's an example where, based on a set of design patterns for smart factory use cases, what Deloitte has brought to market a set of pre-configured suite of solution accelerators called the Smart Factory Fabric. And what the Smart Factory Fabric is, it's a set of pre-configured suite of IoT applications designed for customers that have manufacturing operations, right? And this is powered by AWS IoT, and Deloitte essentially designed and built these suite of pre-configured accelerators. And what it does is, if you're a customer with the manufacturing operations, how can you really help improve your operational performance, reduce costs, improve visibility of your supply chain, optimize production, things like improving quality, and really minimize unplanned downtime associated with your factory. And the solutions that you see here is a set of accelerators that sort of makes it easy to sort of deploy and manage these applications at scale. Now, in another example, and if you look at it from a context of intelligent machines, and look at it from a standpoint of industrial manufacturers want to save costs. They want to save costs with how they maintain industrial machinery. And they want to be much more proactive in their approach rather than being reactionary to the maintenance approach of their industrial machines and assets. And what we typically see in every IoT use case is always ML involved. And what happens is you collect data, you want to apply deeper analytics. So here's Reliance Steel. They essentially teamed up with Tensor IoT to solve a use case in this sort of a domain, which is all about improving the maintenance needs of Reliance Steel. And Tensor IoT is an advanced consulting partner, and they have AWS IoT and AWS ML competencies, and they applied both those competencies, and they also have service delivery designations for AWS Iot Core and AWS IoT Greengrass. So they brought all of those capabilities, and together they built a solution that essentially ensures that Reliance Steel's industrial machinery maintenance needs are met in a much more proactive way rather than a much more reactive manner. So with that, what I want to do is, the next few minutes, sort of wrap up this session. And this partner community has a tremendous opportunity in front of it. And we've talked about the approach to transformation, which is the domain-specific partner community capabilities are built on the foundations of AWS IoT, which is providing a set of broad and deep features. It's proven at scale. It's got multi-layered security from edge to cloud. It's optimized with superior integration to AI. And then this edge to outcome partner community builds on those foundations and drives transformational outcomes across a wide range of industries, in industrial, commercial, and smart home. Now, I'd like to thank every one of you for attending this session. And also, many of you have partnered and helped build this partner community, so thank you for that. And what I would like to leave you with is a set of few pointers in terms of how you can find a partner. You might be already a partner or a customer. Here are some pointers on how you can find one. You may not be a partner today, but here's an opportunity for you to look at, hey, how you can become a partner. You may be a silicon vendor or an OEM that's providing a gateway or a network carrier or a system integrator or an ISV with a domain application, right? All of those are opportunities for this partner community. And then the last piece is, we talked about a set of 5 key accelerators ranging from the silicon program, qualification of devices. We talked about this build, market, sell journey that we take the partner community through. Talked about solutions. There are a wide range of solutions. And then we also talked about some of the system integrators and global SIs, how they're building out these AWS IoT practices. Now, lastly, this is a learning conference, and there are some additional material that I would like to point you to, where these are a set of resources. These are videos, some hands-on exercises where you can explore AWS Iot services in a much more on-demand digital way. And one of the key things that I would like is there's a very popular Internet of Things Foundation series. That's a good place to start. It's a 7-hour on-demand instruction for anyone interested in this topic. So thank you again. I'm sure most of you have questions. Thomas and I and Sean will be here to answer any questions. If there's any questions anyone has now, this may be a good time. Or else we'll be here. We can take more questions. But before I forget, the last thing is, we take your feedback seriously. So do take the time to provide us feedback using the mobile app. We'll look at that. And again, thank you for investing the time in reviewing the session and providing your feedback. So I'll leave it open for questions. Thank you.